This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class session for your own security reasons. Yes, Adrian, I also honestly was like, maybe I could just take the day off and call in sick. But I was like, no, I'll do it. I'll come to class. It's going to be a pretty short class though, guys, so I will let you go a little bit early so you can get started on your break. So today is November 20th, so make sure you open up your ticket. Link is in the chat box along with the password, so make sure you get that open and ready to go. We're going to go ahead and get started. Green checks though once we've got that open. So Adrian, Andres, Angelina, green checks please. Dalen, Destiny, Gabriel, Jeremy, Tucker, Johnny, and Michael and Ty, green checks. Thank you so much. Moving on. All right, guys. So big happy faces, right? We've got no school Wednesday through Friday for Thanksgiving break. That's super exciting. Today we're gonna end pretty easily, right? We're gonna have a nice refreshing game of Kahoot for the Unit 3 game day. You'll get some extra credit, and then we're good to go, and it'll be a nice long break, right? So we've been talking about, let's see here, we've been talking about gas laws, right? Pressure, temperature, and volume. We did a lab on it. So it was a pretty short unit, but we definitely learned quite a bit in it. So what we're going to do is you are going to go ahead and go to kahoot.it. You can go there either on your phone browser or a computer browser. Either one works, so go to kahoot.it. When I give you the game pin, you'll go ahead and enter the game pin, and then it's going to ask for your name. Please make sure you enter your actual name, so your first name and the initial of your last name. No full last names, please. Okay, so please don't type no full last names for your own security reasons, okay? And again, first name, if I call you by a different name in class, it's fine for you to go ahead and put that up there. So if, for example, I call you Jackie, you can go ahead and put Jackie because I'll know who you are, okay? And just make sure you don't put any inappropriate names. Make sure it is your actual name, okay? And let's see here. Then you should be ready to play. Now remember, as always with extra credit games, all you need to do is make sure that you do your best. Okay, let's go ahead, focus in the chat box, please. All right, so remember, all you need to do is you just need to do your best. As long as you're answering most of the questions, you will get your extra credit, okay? So does it matter whether or not we get questions right or wrong in order to get our extra credit? Does that matter? No, exactly. So just do your best. Try. Okay, so Gabriel, again, I'm going to give you the pin in a moment, but you need to go to kahoot.it. And you'll see a little box that asks for the game pin, which I'm going to give to you in a moment. Okay, does that make sense? Let me know if that's confusing at all, okay? Sorry, as I was saying, extra credit is just based on, do you answer all the questions? Okay, if you miss a couple questions here and there, it's fine. But obviously you can't just answer one and then like dip out for the rest of the game because you won't get extra credit for that. And obviously it can only be gotten during live class. Unfortunately, there's no exceptions, even if you have a doctor's appointment or something for future reference. Okay, so go ahead and go there. I'm going to go ahead and get this game ready to go and uploaded. Smiley faces if you are at kahoot.it, if you are ready to enter your game pin. Awesome, looking good. All right, guys, let me go ahead and open this up. Here we go. All right. Thumbs up here if you can see my screen here. Awesome. Looking good. Okay. So let's see here. Game options. Let's see here. Sorry, they recently updated Kahoot, so now it's not set to what I want it to be set to. Okay. So we want to randomize answers, and we want to display and require to rejoin. Cool. All right. Here we go. All right, guys, here is your game pin, 605473. Enter that and then get your name in. Remember, we want your first name and initial of last name. No full last names, please. Go ahead, get your names on the whiteboard up here. Awesome. Thank you, Sarah, Andrew Vega. Awesome. Diego, Elijah. Looking good. Thank you. Good. I'm going to wait until we have the majority of you in here. So just make sure you get your names up here. Again, if you're not playing, you're not getting extra credit. You don't get extra credit just for sitting there. Got to make sure you participate and play with us. Awesome. I see Jonathan. Looking good. Look at all the turkey. Love it. Looking good, looking good. All right. All right, let's go ahead and get started. You can still join. Again, it's kahoot.it, and then the pin is 605473. All right, let's go ahead and get started. Here we go. So gases have indefinite shape, definite volume, indefinite shape, indefinite volume, or definite shape, definite volume. Remember, indefinite means it can change, definite means it can't change. Again, if you're not sure, just guess. As long as you are trying, guessing, doing your best, you will get your extra credit. If you don't answer, though, you won't get extra credit. So if you're not answering, you're not getting extra credit. Awesome. 3 seconds. Awesome, guys. So gases have indefinite shape and indefinite volume. Remember, they can change their shape as well as they're going to spread out to meet the size of their container, right? So if their container changes, then their volume also changes. Smiley faces if that makes sense. Smiley faces if that makes sense. Cool. Annalise in the lead, Jonathan in second, Adrian in third. So let's make sure I'm going to show you a picture of this. Right, so solids have fixed shape and volume. Liquids have no fixed shape, but still a fixed volume, right? The amount of liquid stays the same. Gas, right, can change both. Okay, let me know if that makes sense. Red, not yet. Blue, it's starting to. Yellow, yes. 10 seconds. Let me know if that makes sense. 1. Cool. All right, guys. At higher altitudes, there is higher altitudes, high up in the mountains, more air pressure, no change in air pressure, or less air pressure? What do we think? Again, high up in the mountains, more air pressure, less air pressure, or no change? 10 seconds. Cool. All right, guys. So in this case, there's going to be less air pressure. Remind me again, up in the mountains, is there more or less oxygen for us to breathe? Is there more or less oxygen for us to breathe? There's going to be less oxygen. So if there's less molecules up there, do you think there's more or less collisions? There's less molecules up there. Is there more or less collisions? Yep, less molecules, less collisions, which is going to mean less pressure. Smiley faces if that makes sense. Smiley faces if that makes sense. Awesome. Jonathan in the lead, Edgar in second, Adrian in third. Ariana is the highest climber. Let's make sure this makes sense. All right, I just explained it, but let's take a look at this picture. Again, gravity pulls molecules down. So at the bottom, the molecules are closer to Earth. High up here, there's less molecules, so less pressure. Let me know if that makes sense. Red, yes. Blue, not yet. Yellow, it's starting to. I know, right, Ariana? That was epic. 10 seconds. Let me know if this makes sense. Awesome. Looking good. All right, let's keep on going. Tucker in first, Edgar in second, Adrian in third. So temperature is the force on a container's wall due to collisions, average kinetic energy of gas molecules, or the amount of space gas molecules take up. Is it going to be collisions, kinetic energy, or space? Those are the main words: collisions, kinetic energy, or space. Talk about temperature. What is temperature? 10 seconds. Again, if you're not sure, do your best guess so that you can still get extra credit. 4 seconds. 3, 2, 1. Yes, this one is going to be the average kinetic energy of gas molecules. Remind me again, what does the word kinetic mean? Tell me in the chat box, what does the word kinetic mean? Yes, it means movement or motion, moving, right? So when we talk about temperature, temperature is really just a measure of how fast the molecules are moving. Thumbs up if that makes sense, thumbs down if that's confusing. Again, temperature is really just a measurement of how fast molecules are moving on average. Oh no, Gabriel. All right, let's keep on going. So Tucker's still in the lead, Edgar in second, Vega takes third. So volume, okay, volume is the force due to collisions, average kinetic energy, or amount of space gas molecules take up. Again, collisions, kinetic energy, or space. What is volume? 20 seconds. Hi, Steve. Welcome to class. Go ahead, open up your Kahoot, and then your pin is down here, 605473. 10 seconds. Just do your best, Sally. Do your best. Looking good. Yes. Volume is going to be the amount of space gas molecules take up, right? We saw, I don't know if you guys saw these pictures here, but do you guys remember in like junior high when you had to calculate the volume of a shape, like a volume of a cube, volume of a rectangular prism? Do you guys remember that? Smiley faces if you remember that. So volume is just measuring how much space those shapes are taking up. And same thing with gases. Volume is measuring the space that those molecules take up. Oh no, Ariana? Well, maybe if you take geometry later on, you'll also learn about that. Okay? Looking good. Let's make sure that this makes sense. I'm going to go ahead and show this to you on the whiteboard. So again, pressure is the force due to collisions, volume is the amount of space, and temperature is the average kinetic energy or heat of the molecules. Yeah, it kind of depends, Tucker, right? There are some shapes that it's actually really difficult to calculate volume for, right? Oh, you have? Well, maybe you just don't quite remember it as much, Ariana. I'm betting you probably learned it at some point, but like most things, we tend to forget them the further away they are. 3 seconds, 2, 1. Awesome, looking good. Cool. All right, let's see if we can catch up to Tucker here. So Boyle's law says that an increase in volume results in pressure decreasing or increasing. Remember, increase in volume, the volume's getting bigger, the molecules have more room. So is pressure decreasing or increasing? Remember, it all has to do with collisions. All has to do with collisions. 5 seconds. Awesome, Dalen. I see your answer in the chat box. Oh no, increase in volume, Tucker. It's all good. That's so sad. All right, guys. Yes, in this case, sorry, guys. Boyle's law says that an increase in volume results in pressure actually decreasing. Remember, this is the one that is opposite. Okay, so let's take a look at this, guys. Remember, take a look over here. If we increase volume, do you think that those molecules run into each other more or less? More collisions or less collisions? Tell me in the chat box. Yes, the more room you have, again, it's like Harry Potter's cupboard versus Hogwarts, right? In Hogwarts, there's a lot more space to move around. So as you're moving around, that means you're less likely to collide with other molecules. So there's actually less pressure. Pressure decreases. Smiley faces if that makes a little bit more sense. Yeah, we're taking a look at this left side. Sorry, this was just a helpful hint for you, right? This side has a big volume, this side has a small volume. So big volume means small pressure. Small volume means big pressure. They're opposites. Cool. All right. I'm going to go ahead. Let's go ahead. I know Harry never runs into other people. Maybe on the stairs though, right? So Boyle's law, the volume of gas increases, which means molecules have more room and therefore they collide less, decreasing pressure. I know that was a tricky one. This one's always tricky because it's the opposite, right? It's the opposite trend. It's the inverse proportionally. Sorry, is that what the word was? Yeah. Indirectly proportional. It's okay, we can still catch up. Cool, guys. All right, let's keep on going. Vega in the lead, Jonathan in second, Edgar in third. Charles' law says that an increase in temperature in a stretchy container, okay, if we have a stretchy container, will pressure decrease or increase, or will volume increase or decrease? Again, it's a stretchy container. So think about what's happening as temperature increases, and is that going to affect our pressure or our volume if it's a stretchy container? Container can change sizes. Steve, we're playing a game in Kahoot, so go ahead, log into kahoot.it. The pin that you need is 605473. Looking good, guys. Okay, so in this case, guys, if we increase in temperature, do our molecules want to be closer or further away from each other? Closer or further away from each other? If we're increasing in temperature, we're beginning to sprint around. I got one answer so far. So again, if we increase temperature of molecules, do they want to be closer to each other or further away from each other? Again, imagine yourself sprinting around. Do you want to be closer or further away from people? Yeah, we're going to want to be further away, right? And since we have a stretchy container, can we get further away? If we have a stretchy container, can we actually get further away? Yeah, exactly. So because we can get further away, that's going to increase our volume. Our stretchy container is going to get bigger so that the molecules can get further away from each other. All right, Vega in second, Tucker in third, and Kendra coming up in third. So let's make sure this makes sense. Jump in here. Again, so temperature and volume are actually proportional. As temperature increases, if our container can get bigger, it's going to push open the container, volume will increase. And the opposite's also true, right? If we decrease the temperature, molecules get closer, and the balloon or the stretchy container collapses. 5 seconds, let me know if that makes sense. All right, so again, guys, we can see this here, right? In hot water, our balloon, did it inflate or deflate? In hot water, did the balloon inflate or deflate? Yeah, we saw this multiple times, right? When we put something in hot water, it's going to push those molecules out, and so it's going to inflate our balloon, right? So our volume increases. In cold water, though, what did the balloon do? In cold water, what did the balloon do? Yeah, it got smaller, it deflated, it decreased in size, all right? And the reason for that is because those molecules got slower, they didn't need to be as far away from each other, and so the balloon collapsed in, okay? Smiley faces if that makes sense now. Okay, because I had a couple more people say that didn't make sense yet. Awesome, looking good. All right, Vega in the lead, Tucker in second, Kendra in third. Let's do this. Gay-Lussac's law says that an increase in temperature in a non-stretchy container, like a tank, results in what? Okay, if the container can't get bigger and we increase temperature, what's going to happen? Volume, increase, decrease, pressure, increase, decrease. What do we think? Again, it's stretchy, or sorry, it's a non-stretchy container. It can't change size. So what do we think is going to happen? Is it going to affect volume or pressure? And will it increase or decrease? 4 seconds, 3, 2, 1. Yes, in this case, guys, pressure will increase, right? Can I change volume if it's a non-stretchy container? Can we change the size if it's a non-stretchy container? I have not, Dalen, because I'm afraid that if I start playing it, I will get addicted to it. No, right? In a non-stretchy container, we can't change volume at all. So volume is definitely going to stay the same. It's not going to increase or decrease. On the other hand, if I'm increasing our temperature here, imagine we are trying to warm up this tank. If I warm it up too much, what's going to happen? If you heat up this tank too much, what's going to happen? Yeah, it's going to blow up. It's going to explode because pressure is increasing so much, right? The temperature is increasing, and those molecules, because they can't move away from each other, they're going to be sprinting around in this small space, colliding, 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 until at some point the pressure becomes too much and it explodes. All right? Awesome. Still same leaderboard, Vega, Tucker, and Kendra. Let's make sure that this makes sense. Let's take a look at this. Right? So again, Gay-Lussac says that temperature and pressure are also directly proportional. One increases, the other one also increases. One decreases, the other one also decreases. Let me know if that makes sense. Again, hotter, more collisions, more pressure if we can't stretch the container. Gotcha, Dalen. 3 seconds. All right, looking good. Let's keep on going. So last question here. Compressing a gas makes its density, again, compressing it, right, squishing it together, does it make its density decrease or increase? Okay, take a look here. If we squish this gas down, is the density going to decrease or increase? 18 seconds. Let's make this count. Make sure you participate so you can get your extra credit. You got to participate in the game. Awesome, Dalen. I see your answer. Excellent. Yes, in this case, it's going to actually make its density increase, right? Take a look at these molecules. If I squish them down in this container, do they get closer or further away from each other? Do they get closer or further away from each other? In the chat box, tell me, do they get closer or further? Yeah, they're going to get closer together. And the closer molecules are, the more dense they become. Okay, so density increases. Awesome. Vega in the lead, Kendra in second, Tucker in third. Let's make sure that this makes sense. All right, so again, compressing a gas increases its density. The molecules get closer together, more dense, and this is how a diver can use its gas tank to sink, right? It becomes less buoyant, more dense, and so it sinks. The opposite is also true. Decompressing it decreases density, you become lighter, and you float, right? Let me know if that makes sense. 5 seconds. All right. Kind of depends. If you think about like chocolate foam would be much less dense and could float, right? However, if it's super dense, then the chocolate will definitely sink. It's like the difference between Diet Coke and regular Coke. If you put a can of Diet Coke and a can of regular Coke into a tank of water, one of them floats and one of them sinks. So think about this. Tell me, guys, if you've ever held an artificial sugar packet versus a real sugar packet, which one's heavier? Artificial sugar or real sugar? Which one's more dense? Yeah, real sugar is more dense. And so the result is in a tank of water, if you put a can of Diet Coke and a can of regular Coke, the can of regular Coke will actually sink because that real sugar makes it more dense. Whereas the can of Diet Coke will float because the artificial sugar is much less dense. And so it's not dense enough to sink. Smiley faces if that makes sense. Okay. Yeah, hopefully that should make a little bit more sense to us. Cool. All right, guys. So let's go ahead and get our results here. Go ahead, give a round of applause to all of our players today. Vega, Kendra, Tucker, Diego, Edgar, congratulations on getting on the whiteboard. I'm going to go ahead and save these results really quickly. Awesome. Great job, Sienna. That is an excellent effort. That's what happens when we try our best. All right, let's go ahead. Here we are. And what's today's date? 20th? Yeah, okay. And you guys are last names N through Z. Cool. All right, here we go. All right, guys, so that being said, here is your last word. If you missed the ticket, here's the link to the ticket. Go ahead, open that up. Here's your last word, and I will see you all later. Thanks so much. Bye, everyone. Have a wonderful break. Hope you get lots of good food and you have lots of sleep and fun. Bye, everyone.